is materials testing was kind of these journalistic questions. Where? What's our sampling point? Because that sampling point from a point of legal standard is our point of acceptance of that material. And then how do we sample? Again, based on the point of acceptance, as we talked about in aggregate class, with the cold feed belt sampling, but we looked at windrow sampling and stockpile sampling and so forth. And then the next question is how much? And again, our whole key here is we want to get a representative sample of the material that's going down on the road. So that should always be the overlying objective. And how much kind of dictates to us is obviously we need enough material to run the tests that we're required to do, but and there's minimums in the field sampling and testing manual, but those are always minimums. You never want to try and sample to a specific weight, number one. And if you overrun, that's actually working in your benefit. The bigger the sample, the more the probability is that it's going to be a representative sample. So you shouldn't worry about that. And then how often are we sampling and testing? And then, we're not doing this just for fun, is what's our specification compliance? So whatever we're testing, what's the specification targets? And that can be an upper and lower spec limit. It can be a minimum or a maximum. And then a thing to remember is anytime, and the question always comes up, and it's a valid question when you're running a laboratory, is what level of accuracy do I need to test and report to? And the first really hack there for you, key there, is that if you're ever not sure, go to the specification. And whatever the specification lists, if it's a whole number or a tenth or a thousandth, then that's what I have to report to. And that also then triggers how I do my interim calculations. If I'm reporting to the thousandths, when I'm doing my interim calculations, the thousandths, of course, is 3 points to the right of the decimal, which specific gravities fall into that category. Then guess what? I need in my interim calculations to be out 4 or 5 decimal points, so that when I finally round in to give my answer, report my answer at the level of accuracy required for the specification, I'm rounding correctly. And then after that, the next question is what if? What if it doesn't meet these requirements? What do I do about it? What's my mediation action or my remedial action or non-compliance measures that I have to take? And then with QC QA, the loop that closes the circle with QC QA IA is we have to check each other. And this isn't just the test result and whether it meets specification, it's the test result itself. Is the test result on either an independent sample or a split sample for the same population of material, say a day's production, for different labs, different operators running the same test, those test values have to be within certain tolerances. And if they are, that tells us that we have similar operations and sampling procedures. If not, it's a sign that we have a problem going on someplace. Might be in the test apparatus, might be in the sample, might be in the operator. But it's a trigger to get things right, I guess, because the only thing worse than having no data to make decisions on is having bad data. And so what we're trying to avoid there is bad data. And then, of course, the what if. What if we're outside of those tolerances? And that sets in motion kind of a dispute resolution. It may be as simple as resample and retest, but a lot of times you're going to continue down the trail of, checking oven temperatures between labs, checking water bath temperatures, checking balance and scales,